Okay, so this is year 12 and this is the extensions functions work. Alright, so just running through these graphs again. So y equals f of x and the absolute value of x. Basically, to sketch that, you need to sketch y equals f of x and y equals minus f of x. And then once you've done that, then you sketch them. Like, so say for example, this is your curve, then that's y equals f of x, you sketch y equals minus f of x, and then the next thing you do is you rub out below the x-axis, because y is the absolute value of f of x, and you're unable to do that, so you've got to, you're unable to have a negative value, it has to be a positive value, so that's why you have to rub out below. Okay, alright, second thing, y equals 1 over f of x. So basically what that means is, the first thing is, on the x-axis, where it cuts, that's where y equals 0. So that's actually where f of x equals 0. So if you went 1 over f of x, it would be undefined. Where it is undefined, that's where it ends up being an asymptote. So that's your asymptote. Okay, so if you were drawing that and you had this curve here, then that means that your asymptotes would be basically here, here and here, and it just means that the rest of it gets flipped, because you need to flip every single other y value. So you flip the y value. So whereas y is normally f of x, it becomes 1 on f of x, so every function value to get the y value gets flipped. Now, when you flip numbers, if they're bigger than 1, like 2, they get smaller. But if they're like a half, they get bigger. And when they're like equal to 1, it stays the same, because if you flip 1, you get 1. So basically, everything gets flipped. All right, the other type of graph, that's a reciprocal one, is root f of x. Now, root f of x, basically, on the intercepts where y equals 0, square root 0, you get 0. So the x-intercepts will stay the same. So the x-intercepts are exactly the same. So if you sketch this, and it was like that, and that was minus, say, 3, and that was 2, then all of these x-intercepts will be the same. Okay. What happens with the rest of the curve, if that's 4, what happens with the rest of the curve is when you square root it, if it's actually bigger than 1, then it will get smaller. So the square root actually flattens the curve. Where have you heard that before? Okay, so it will flatten the curve. So it brings it down, because if you square root it, you bring it down. Now, you notice when I drew that, I didn't actually mention this, which is really quite important. You can only square root a positive, or you can square root 0. So you cannot square root the negative. So that's why you have to rub out below the x-axis. So all the curve that's below it isn't going to be counted, and this basically ends up being the only part of your curve from 2 and there down to minus 3 that can count. Now, further on that, something that's really quite simple, if you want to do y squared equals f of x, not root f of x, then that there produces y equals plus or minus root f of x. So if you want to sketch that, you have to sketch two things. You have to sketch y equals root f of x, like we did on the other page. So you flatten the curve, you bring it down, and y equals minus root f of x. So what that means is, once you've sketched y equals root f of x, all that you have to do is you just reflect y equals root f of x in the x-axis. So you just reflect it into the x-axis. So if you were sketching like that one above and it was like, so that's minus 3, that's from 2, then when you reflect it, that means you draw the other half of the graph here. Okay. Now there is one more that is in the syllabus that I haven't done, which is that when the absolute value is inside. This one here affects the x. It doesn't affect the y. what it means is if you put in x that's positive, you get the same as if you put in x that's negative. So f of the absolute value of x, f of positive x will equal f of minus x, because when you absolute value something, it becomes positive. So you basically get the same. So this will create symmetry, and the symmetry will be about the y-axis. So if you fold it on the y-axis, it'll be the same. Okay? So basically, what happens is the steps you draw the right-hand side of the graph. So if you have this, you really only need the right-hand side of the graph. So this disappears. So that was 3 to start with, and then what you do is you have to reflect. You reflect the right-hand side in the y-axis, so it's the same. So you get it, and you just go boom, and you go, all right, that's minus 3. Okay, now just doing the questions off the slide. Okay, so just running through the questions off the slide. First, y equals the absolute value of f of x. That would mean that what we need to do is we need to sketch f of x, and we need to sketch minus f of x, and then we need to rub out below the x-axis. So if I sketch f of x, that's going to be like that at A. So there it is there. Just do it on here. And then if I sketch minus that, then that's going to be like that. And then what we need to do is we just rub out below. And that's basically what your curve will look like. It goes like that, and then goes back up. And that is A, and what's that? B. That's B there. Okay, so that's part A. So part B, 1 over f of x. So 1 over f of x, I'll do it up here on the curve. So basically, you have asymptotes at the intercepts, and everything else flips. So it still stays in the same quadrant, keeps the same sign, it all flips. So that means you've got asymptotes at A, asymptotes at B, asymptotes at A. You have a curve here, here, and here. And any values that you have there, like if they did give you that value there, was like if you wanted to work out what the value was, like that one there, sorry. Say that value there was 3, minus 3, then that value there would be minus 1/3 for the y-intercept. So, you flip the y-intercepts. Okay. And then the last one, which is y equals root f of x. And from that, we could also do y squared equals root f of x. So if you have your curve here, and what that does is you can't have anything underneath the axis, you can have 0, and this one gets flattened. So it actually ends up being a dot, and ends up being a dot, and it ends up being like that. So it's like that at B, and a dot at A. Now if you were then further asked to sketch y squared equals f of x, you would keep the dot, and you would just reflect that into the x-axis. And further on that, I know that we don't have it, but if we did, we were asked to sketch the absolute value of x. That's an even function, so you keep all the stuff on the right-hand side, and then you just reflect the same thing, because that is even on the other side, so you reflect it. And that would be y equals f absolute value of x. Okay, so looking at this one here, the first one is y equals the absolute value of f of x. So that means that you basically sketch the normal one, and then you sketch the negative of that. So that's going to go, there's your asymptote, that's going to go like this, and through there, and like that. Alright, so I've done both of them. Alright, so then the other thing is, because absolute value equals a positive, then you've got to rub out below. So that means that you will have your asymptote there. So that one will go up like that. This one here comes back up like this, and that one goes up like that. And the asymptote is really asymptotic just for this one here. and that number there is a 3, just there. Okay, so that's A. Now B, y equals 1 on f of x. So I'll do it straight on the graph. So where the x-intercepts are, that's your intercepts. And 1 on f of x means everything else gets flipped. Flipped and flipped. Now what's happening here? Now even the asymptote gets flipped. So the asymptote goes to a half. And all of these values here, let's have a think about what happens there, because I'm actually not sure. Let's look. If I have 1/3 and I flipped it, I actually get 3. So what happens here, this curve when it's flipped, it no longer remains on this half of the graph. It gets really quite bigger because you're flipping smaller fractions. Let's just say we have 3 on 2 as well in there. So that goes up to 1.5. Okay, so yeah, your asymptote will be new. Alright, so your asymptote won't be at 2 anymore, it'll be at a half. And all these small ones flip and get bigger, because you think about it, if you have like 1 on 10, that will become 10, so it's up the top there. So instead of being there, it flips, and the asymptote is down here, and that number there is actually 1/2. So when you're doing it, that goes to a half, and that flipped there. This one here is an asymptote, that one there's an asymptote, that goes there, and this one here goes here. Okay, so we're just going to get rid of that. Alright, so now we're looking at C. C is root f of x. So root f of x on this. Root f of x means that anything that's below the axis you don't count, so that's not going to count. Anything else like 0, it gets flattened, the square root brings it down. Even the asymptote becomes root 2, and this all gets flattened. So the asymptote goes down to root 2. This comes up to the asymptote and all gets flattened. And where you have this value here, which was a 3, the 3, it's the curve just gets flattened and it comes down. Now if you had to do a D and you had y squared equals f of x, you just take that curve and you reflect it. Like that. Okay, and that would be 3 and that would be 0. And if you had y equals f absolute value of x, that would just be, so you just take what's on the right hand side, which is this curve, through 3, and then you draw a symmetrical curve on the other side, because you get the same value for plus or minus x. The next one, this one's for y squared equals x squared minus 2x. So first, if you sketch this one, x minus 2x, it's going to be 0 and 2. It's going to look like that. And then if you're going to do y squared, you need to first do y root f of x. So if you did y root f of x, it's actually going to flatten. It's going to go like that. Even that will be flattened, but because it's root f of x, I take that back. That's got to disappear, hasn't it? So we'll just get that back. All of that under there needs to disappear because you can't square root a negative. So there's no negative. Okay, and everything else gets flattened. Now, when you do the y squared part, all you've got to do is reflect it. So you get this and you reflect it there, you reflect it there. So basically, that parabola curve would look like that, and it will look like that through 2, so we're looking like C as your answer. This one's got a few interesting things. You've got y squared equals 2 sine absolute value of x. So the interesting part first, if you sketch 2 sine x, so with 2 sine x, that's going to, sine graph starts there and goes like that. That's going to be pi and 2 pi. Now, if we put in an absolute value of that, so sine x with an absolute value, it just means that you keep this half of the graph and then you do the same symmetrical things. So this part here now goes. And then lastly, the next thing, so we've got y equals that. We need to sketch the square root of that. So all that that's going to do is get rid of anything that's negative. So we'll just rub those out and we will flatten it. Okay. Now, by the way, too, if you had to keep drawing that, that would go like that, and then like that, and then we get rid of that. So it just becomes, so it might have like one hump there, but it has 2 in the middle, because that's where it was positive and then it was reflected. So that's pi, that's 2 pi, that's 3 pi, 2 pi, and yeah, that would be 3 pi. Okay, so looking at that now, that's not y squared yet. It's been flattened as well. It does, like the square root of 1 still stays the square root of, like if it, it goes to 2. That will go up to root 2. My apologies, root 2. Because if you look at that, that's the amplitude, and that tells you how high up and how low it goes. Then you need to reflect it, because it's a y squared 1. So if you reflect it, that's basically what your curve would look like. And it keeps going on like that, etc. Okay. Okay, now looking at this one here, so it's got this curve, right? Now, that's actually not a separate question. So which curve represents that? Now, when I go back, which curve best represents that? Oh no, it is a different question. Let's just say which equation best represents this. So we've got this, we've got options. So we've got y equals root x. You've got y equals, the absolute value of y equals root x. Then they've got y equals the absolute value of x. And then after that they've got the absolute value of x equals root the absolute value of x. Okay, so let's just have a look at this. So with this curve, basically it's symmetric about the x-axis, you can see that. So that means it's got to have an absolute value of x in it. If it was this one here, that means that could be plus or minus that. So it can't possibly be that, because if it was plus or minus that, we'd have to have like the minus version and something down here as well. So what that means is that the answer to that one would have to be C. Y equals root x would just look like that's just 1/2 of it, and this one here would be minus root x and plus root x as well, so that's why that's out. So the answer would be C. Okay, so looking at this question here then, first we're going to sketch this one, which is x plus 4. So the roots are at 0 and minus 4, and it is a positive, happy graph like that. Then when you go, if you're looking at that, if you want to do 1 over that, so you're going to do 1 over the function. The asymptotes are here. Everything else gets flipped. So basically that's your curve. Oop. That's your curve. Let's get rid of that. All right. Okay. So number 6, let's say, this one. All right. So the question says, suppose that f of x is a non-zero odd function. Non-zero, that means it's not 0, and it's an odd function. Which of the functions below is also odd? Now, just remembering that an odd function means f of minus x equals minus f of x. So you've got to test these out. So if we've got f squared, what would f of minus x equal? F of minus x will equal, where there's, that means that would be the same as, so if you want to do f of minus x into this, that means that you would have to put in, so you want to do f of minus x. So f of x is odd. That means you would have to, if you put in x squared, you just get x squared. But if you put in minus x, then you get minus x squared, and you get f of x squared. So in that situation, f of x squared, and it's cos x as well, isn't it? That's positive, and cos x and cos minus x. Now, cos minus x is actually equal to cos x. Remember, sine minus x is sine x, and cos minus x is cos x. Sine minus x is minus sine x. So sine minus x is minus sine x. That's because it is in that quadrant. sorry, in this quadrant, doing some mistakes, sorry. That's because minus x is in that quadrant and sine will be negative. That's why it's equals minus sine x. But cos minus x equals cos x, and that's because in that quadrant, cos is actually positive. So if you look at this here and you want to do f of x, so a is definitely out, because if you put in a negative and put in a positive, you get the same thing. That means that that function for a is not also odd, it is in fact even. Okay, so now if you look at the next one, it's f of x. Okay, so f of x. Now, if f of x is odd, then that means that f of x, let's just write that you got that equals that, doesn't it? So that means that f of x actually equals minus f of minus x. So if you put in a negative, you get the same thing, but it'll be a different sign. So let's just have a look at that. F of x would be, if it was odd, it would be the same as that. Now f of x is odd, that means that f of minus x would be minus f of minus x. This is a very, very hard question to understand, I think. Is that odd? Will we get an odd function? Yeah, I think in fact we would. Listen, I'm thinking the best way to probably for me to explain it, because I think I'm explaining real well, is just to put, if I put in x is 1 and I put in x is minus 1, do I get the same thing? Now, it tells you that f of x is odd. So that means that f of 1 will equal minus f of minus 1. That's a statement, okay? So when you're testing these out, let's look at A. F of x squared, so that's f of 1 squared. F of 1 squared is f of 1, okay? According to the rule that it's odd, that means that that would equal f of 1. If you put a 1 in there, and we've got the cos, haven't we? Let's not put 1 because that's not going to help us. So you have pi. Okay, so let me just look at that again. I'll just reread it. So basically what's saying that is f of x is odd. Now, if f of x is odd, that means that if I put in a, I get the same thing as I put in minus a, but it will differ in sign, it'll be a negative. So f of x equals minus f of minus x. Now if you look at a, you've got f of x squared. So if I put in x, I get f of x squared. But if I put in negative x, I get negative x squared. Sorry, and I should also, I keep forgetting that cos on this one. You get cos of x. But if I put in a negative, then you get negative x squared, cos of negative x. For that to be even, when I put in a positive and a negative, it should be the same thing, but it should have a different sign. Okay, so now cos of minus a is just cos a, because that is in the fourth quadrant, and cos is positive in the fourth quadrant. So that means that's going to be f of x squared, that's cos x. So that means that you don't get negative f of x squared, negative f of negative x squared. That's not going to work. So that means that it's not a, because they're going to be the same thing. If I put in negative or if I put in positive, I'm actually going to be the same thing, and that one is even. Okay, so if you look at B, we look at B. B is f of x. So if I put in a positive x, that's what I get. If I put in a negative x, I get this. So that's f of minus f of minus. F of minus x equals f minus f of x, because that's from the original statement up here. So f of minus x will equal minus f of x. So you can then replace it. Now, once you've done that, then, this is f of minus a, which equals minus f of a. So that's going to be minus f of x, because a is f of x, which then makes it odd, because f of minus x equals minus f of x, if you know what I mean. It's a pretty hard question, and it is this is from a 4-unit paper, so that's why it's so hard. Okay, there's just a couple more things that I want to look at. These are probably a bit hard, but e to the minus x, and also x plus e to the minus x. Now before I do that, I just want to go through when you multiply two functions. So if you have y equals f of x and you have y equals g of x, and they're drawn on the same diagram, so that's 3 minus 2, that's f of x, and g of x, let's just say g of x looks like that. So that's y equals g of x. Then basically what will happen here is when you're multiplying, if you look at where all the x-intercepts are, if you do f of x times g of x, then wherever they are 0, the y-intercepts will be the same. Because when you multiply the y values, if f of x, cf of x equals 0 at minus 2 and 3, so that means the y values are 0. So therefore when you multiply that times g of x in that case, it'll be 0 times g of 2, or 0 times g of 3. So that means that at those points there, that means that it's going to be 0, and that's all good. If you look at these here, they are positive y values, and what we do is the shading regions method. I don't know if you remember this. This is a positive and a negative, so it'll be a negative. This is a positive and a negative, so it'll be a negative. This one, what have we got here? We've got a negative and a positive, so it is also going to be a negative, okay? So it's negative, negative, and positive. So when we draw it, where this up here is where we have one part of the curve. We go to minus 2 here, we come back down there, and then we come back down there. We've just got to make sure that when we're sketching this, that we stay in the region where the values are. So what you're doing is you're looking at the signs of the y values. Let's go back and just apply that on the one that's on the slide. So x, there's y equals x, and that one. So basically at 0 is where you look, basically there's what's important. If you look at that, this part of the curve here will be, all that there will be positive. And this is a positive and a negative, so when you combine those and you multiply them, you get negative. So basically that means that this here is going to come up here, and this part here, this is going to bring the curve down, it's going to pull that curve down. I think what actually happens, it becomes asymptotic with that line there. So it kind of goes realistically. I don't know if you have to go into that much detail. When they're in 4-unit, they certainly did, but I think that's probably going a bit far. So when you look at that, it actually becomes it goes like that, but it actually approaches that line y equals x, because that's what exponentials do as they get really, really big. So basically one curve looks like that, and like that. That's basically what your curve looks like. Okay, now the summing one. I don't know if you remember this, but it's probably the one I least like. So we've got y equals x squared minus 4. So you've got minus 2 and 2. And then you've got y equals x, and you're going to put that one in. So we're going to go y equals x. Alright, let's just say it's x plus 1. Okay. So what we've got to do here is when we're adding them, we've got to add the y values. So when you're here, you're just adding a y value. That one's 0. So that's where your y value is going to be. It's going to be there. Alright, so any of these, where it cuts, the y value is 0. So it's going to keep the curve that's actually there. Because basically what you're doing is, you're just adding on the y values. Now, if you look at this, if you add this y value here and this y value here, the green one's bigger. So that means that it's going to pull your curve somewhere down there. If you come along here and you add this y value and this y value, they're pretty much nearly the same. So it's going to actually go through there. So I'm just using big blue dots. And you can see you're getting the shape of it here now. Even if you added that little one, it would come off this big one and probably go somewhere there. So it comes down here like this, up here, Then we're adding this one to this really big one, so it's up there. And that really big dark blue curve here, that's basically what your new curve will look like. Like that. Okay, so if we come back, and we're looking at adding this one, so we're going to add them now. So if we add 0 to anything, that stays the same. So if I was doing this, I'd do my zeros first. Then I go a big plus a little one, so it just adds on a little bit. So by doing that, you can actually see, where the curve is going. This here, this will be twice as big, see? But if you add, there's going to be a point here where this one here equals that one. It's going to be somewhere there. And when you get to that point is actually where it intersects the axis. Now, which one's going up more rapidly? I think actually, if you look at that, yeah, if we keep going, I'm just going to put in, if I put in x equals 0, I'm just going to check something. So if I put in x equals 0, I get 0 plus e to the 0. So I get 1 there. So that will go through 1. And then as you look here, I feel like this is actually, this curve here goes up more quicker and steeper, more rapidly than that one. So what's going to happen is it's going to pull it up. So it's going to basically go like that. Will this ever equal 0? Because that's where it will intersect. Like if you put that in, that is not possible because you can't have an e function to a power to get like a negative. So you'd never get that negative x.